Yeah, thank you, JT. I don't know if I'll do much better, but it's a delight to have Jans back to talk to the Semantic Arts community at the Estes Park group here. We were able to connect you and I, Jans, just briefly over dinner at Data Day in Austin, Texas. Although I didn't get a chance to talk to you about any of the specifics there, but in any event, Jans is a CEO and inspirational leader at Franz, based in California, and is the lead developer of AllegroGraph, semantic knowledge graph triple store product that Semantic Arts, by the way, is quite fond of, and we oftentimes use that as a sandbox for numerous pilots. I don't know, Jans, exactly what you're going to be sharing with us today, but it's always very compelling and interesting. So I'll just pass it over to you to continue with the introduction and give us an insight as to what the context of the discussion today will be.
Before we go on, right? So, how much time do we have?
Hey, Jans, your sound is really bad.
Oh, let me. Okay. So it's a headphone. Okay, is this better? My
Yep.
voice?
Yep,
Oh,
that adjustment worked.
I just have a new headphone. I think it's incredibly sensitive to where my microphone is. All right. So this works good.
Yep.
All right.
And today's
Okay.
session's about an hour, so however much of that you might want to take versus kind of leave open for some Q&A.
Yeah. All right. So Steve already introduced me, right? So I'm the CEO of Franz Inc. and we've been in this field for about 15 years, the field of semantics. So I'm going to talk a little bit about my experiences, recent experiences. And let me first find my presentation and see if I can share that. All right. Okay, I'll just share my entire screen. That is usually handier with more. The share button is gone.
Should be in the upper right, right next to the big red
Oh,
leave
there's, yeah, got
button.
it, got it, got it, got it. Yes, got it, got it. Entire screen. And then this one here, share. So you guys see my screen right now? PowerPoint.
Yes.
Got it.
Okay. Let me make it bigger. So do you now see the presentation mode?
Yes, from data warehouse to Datafabric. Yep.
Okay. All right. So Craig told me, Jans, you promised that you would give a talk. Hey, where's my whole? So okay. Craig told me a week ago, Jans, you promised to give a talk, and it's about semantic layer. And then yesterday I saw it was actually about Lakehouse, but actually I don't think it matters that much. So anyway, I'm going to talk about how can we bring semantic technology to Lakehouses, Datafabrics, and semantic layers. And um, and so I'm going to talk a little bit about the difference between a Lakehouse and a Datafabric. What is a semantic layer and how does it relate to a Lakehouse and a Datafabric? And there's a beep beep. Am I in the meeting?
Yep. Sorry, that's folks coming into the meeting. I'm getting them in.
Okay.
But yep.
Yeah. And then can a lake house and data fabric and then semantic layer live without our semantics, like RDF semantics? I'm going to talk about an earlier maturity model that I used. That was before I had all the terminology that now is common, right, in the world of lake houses, data fabrics, data lakes, and semantic layers. Um, I'm going to talk about it, and then I hope to open a discussion about if I had to do a maturity layer again for how you can use semantics within the area of Lakehouse and data fabrics, how would you do it? And I don't have a solution, so I hope to tap into your shared wisdom here, right, to help us with that. All right, so let's first look at the difference between the Lakehouse and the data fabric, right? Sorry, I'm in a presentation. Um, So, so I used that. This is, by the way, there was a fun little project for me to create this presentation because I used ChatGPT left and right, right, to see if it could write the presentation for me, right. And so I began with. So I asked the question, what is it? Can you give me some examples of lake houses, right? And it came up with Delta Lake, Apache Iceberg, Redshift, Google BigQuery. And what you see from this, it's very, very cloud oriented, right? And there's absolutely no RDF inside, right? Even if you do a Google search for RDF plus Delta Lake, right? Then you find semantic vendors like us, Stardog or whatever, right? Some links, but nothing from the community in Delta Lake itself. Anyway, so that is lake houses. So then I said, okay, so what vendors offer data fabric solutions, right? And then you see the usual crowd, like Informatica calls themselves now a data fabric. You know, the common pattern is the analysts see what's going on. They try to kind of create a theoretical framework for what they see in the market. And then every big company with the big marketing budget suddenly does data fabric, right? So Informatica, Talent, Denodo, IBM, Oracle, SAP, right? All do their data fabrics, and of course, no RDF inside, right? So then a thing that I was kind of confused because I've done a lot of Google search, saw a lot of presentations. So what is really the difference between a data fabric and a lakehouse, right? And give the answer in bullets. And so, right, what you see here, data fabric provides a unified and consistent view of data regardless of where the data is stored and how it's accessed, supports data governance security. It's about data integration. It uses a little bit of virtualization, data cataloging, metadata. But then if you look at the definition of lakehouse, it's almost the same, right? Also a unified and consistent view of the data, regardless of where the data is stored, and supports data governance and security. I think the biggest difference is that data fabric is very much an architecture, but it's almost like a theory of how you should do your architecture, whereas lake houses are very down to earth cloud-based cloud-based systems, right? And if you ask around and Google around, you'll see that lake houses actually should use a data fabric too if they want to be better at it, right? Again, if you look at the regular descriptions, no RDF inside, right? And then we get this whole very new concept, right? That just came up, I think, maybe just in the last 2 years. Is the semantic layer, right? And so there are several vendors for semantic layers. But when you get, if you look at this, and you know, a semantic layer, I mean, I don't know if there's anyone in the audience that used business objects 30 years ago, right? Which I think was the first real semantic layer, right? Where people said, okay, we have to make an abstraction from the the IT infrastructure and give something to the business users, right? So they can think in business terms. And I think they invented, to some extent, the whole concept of semantic layer, right? Except at the time they didn't really call it that way. And no one has gotten any further than that, right? But anyway, what you see here, it's Tableau, Business Objects, Click, Microsoft Power BI, Apache Superset, right? It's all what they call the semantic layer, but all they refer to is actually this part of having a translation from business objects or business views to underlying data. The thing, of course, is there's no standard technology for that. I mean, RDF would provide it, right? But again, if you look at these, no RDF inside. So, and then if you go to people that provide these semantic layers, then it's kind of interesting. So this is an article that I found on Airbyte, the rise of the semantic layer, and you can look at what is it, what is the history of semantic layer, what is the rise of the semantic layer, what are the tools available, problems, etc., etc. But the super cool thing is, you look for RDF, you look for knowledge graph, you look for semantics, right, with an S plural, you just won't find it. It's fascinating. Now I have to say, I'm my background is I'm a cognitive scientist, right? So for the last 35 to 40 years, I've been thinking about modeling human behavior, AI systems that do that, and all I ever thought about was semantics. So I thought that the way I thought about semantics, that was the right way, right? How people think, right, and how they do assign meaning. But I found out it's totally wrong, right? But anyway, you get my point, right? So it's I feel territorial about the word semantics, and I'm kind of pissed off if I see that they appropriated that term without any history of what semantics really means. Anyway, let's continue. Then, do lakehouses include a semantic layer? Give answer in 7 bullet points. And then the ChatGPT will say, yeah, typically there's a semantic layer as part of the architecture. And then it talks about all the things that the semantic layer can actually provide. But again, no explicit reference to RDF. The same thing for Datafabrics. Do they include a semantic layer? And again, give the answer less than 7 bullets, and yes, it does the same thing, right? And it's again simplified view of the underlying layer. It's about metadata, data models, and data mappings, right? So, so they all use the same language, and it kind of doesn't even matter whether you look at Datafabrics or Lakehouses or semantic layers. It's all the same terminology: unified view, data integration, data mapping, right? So then I wanted to know, so can you have a semantic layer without semantic technology? And then they say, yeah, without any shame. Yes, it is possible to have a semantic layer without using semantic technologies such as RDF, ALL, or ontologies, right? And then they talk about all the elements of semantic layer, again, data modeling, data catalog, data integration, and business glossaries without a technology or a standard, right? So basically the idea is every vendor can come up with their own data modeling technology, data catalog technology, data integration technology, or business glossaries, right? And just do whatever you feel works well for your solution, right? But okay. So I asked, so can you have semantic layer without semantic technologies? But why do many vendors of semantic layer not include RDF, ALL, ontologies, and other semantic technologies, right? And so basically, it's well, according to I mean, ChatGPT is basically takes the collective wisdom, right, of where it finds the most literature, right, and they'll summarize that. So it says, well, it's because lack of demand, and it's in semantic technology is way too complex, and this really irked me. It's you can't interoperate with semantic technology, right? I mean, the whole thing is that semantic technology was built so that you could be interoperable. Anyway, and the other one is that say, well, we don't need RDF because some vendors don't even require it, right? Such people in financial services and healthcare. And accidentally, all my customers for RDF and our knowledge graphs are in financial services and healthcare, right? So kind of interesting to see what the common wisdom is. And then it's hard to find expertise, which to some extent is true, right? By the way, I'm talking to a screen here, guys, so help me out if you have any questions or comments. Please, I really welcome interruptions, right? So anyone?
Great so far. Great so far. Carry on.
All right. Okay. Well, that helps too. And yeah, I was.
We do have some people who have their hand up.
Say it again.
So
you have some people.
Well, some people have raised their hands. So
yeah, I'm looking at this huge.
Somebody needs. Yeah, you can't see them, but.
So can someone maybe read those comments or ask something based on that? Otherwise, I'll just keep on droning, right?
Well, I could just jump in. This is Michael Sullivan from Oracle. Oracle's data warehouse, autonomous data warehouse, has built-in RDF in it. So I
I
guess
know.
there is. I guess there is an exception to your statement. Yeah.
You mean there's a redeeming quality, right? Yeah. No. No.
Mhm.
I mean, this is just what ChatGPT is telling me, right? So, and by the way, anyway, okay, let's continue. So, and I was kind of doubting whether I want to show this picture here, but we did meet a company that had a name that I was really jealous of. I thought I had called our company Semantics, right, with an X. I mean, that captures what we do, right? And but of course, it was taken already. And so I talked to the people that built a cloud-based platform that they call Semantics, and so I'm in discussion with them. I said, so, but where is the semantics? I mean, do you have a semantic layer, an ontology that does the mapping from business concept? And they said, no, well, not really, right? And anyway, so they challenged me to find out. We did a little project of all the places where you could add semantic technology, but let's not go too deep in here, right? But that's basically the state of the industry, right? You call your platform a semantic layer, and then but you don't have a standardized semantics. All right, so let's continue. So what ChatGPT showed us was basically a reflection of what I would call the late majority, yeah, trying to incrementally improve their IT processes. And in itself, there's nothing wrong with it, but we'll forever be stuck in the world of SQL and schemas from various vendors. Without a real standard, right, on how to add semantics to whatever for everything that you have, right? To some extent, it's just lipstick on a pig, right? And so that is the state of the world, right? And but then you see the gardeners and the foresters of this world, right? That talk to innovators and early adopters, right? I mean, gardener and forester never really predict the new technology. They basically look at the market, see what's coming up, right, and then reflect on that and write reports on that and make money on that. So, I think this was a 2021 paper by Gartner about data fabrics, because every analyst that I know was writing a report on data fabrics, right? And they said, well, the key pillars of data fabrics are the data integration layer, right? And a knowledge graph and active metadata analysis and data catalogs. So, and then there's some more pictures here, right, where you have your data and the metadata. You have an augmented data catalog, and then you have a knowledge graph that tries to tie everything together all the way up to the data consumers. So I actually asked ChatGPT, why does Gartner say that semantic technology like ontologies, taxonomies, and knowledge graphs are essential for lakehouses and data fabrics? And let's not, let me here, put it here. Let's not read all the stuff here, right? Because that's too much work. But in summary, semantic technologies are essential for lakehouses and data fabrics because they enable better data organization, integration, search analysis, leading to improved collaboration, decision-making, innovation, right? So Gartner is really priming the pump with what they're doing, right? And we're very grateful that Gartner is in that particular stage. And we've actually talked a lot to Gartner in the last 2 years about some use cases that we're doing about data fabrics. And then you can also ask analysts, why do analysts recommend the use of semantic technologies like ontologies, taxonomies, and knowledge graph to implement the semantic layer? And again, you get the reasons that you guys in your work, because most of you are all consultants, right? You all talk about the same thing, improve data consistency. And you get that by enforcing consistent data models, ontologies, taxonomies, and knowledge graphs, enhance data integration, facilitate data discovery. It goes way better when you have a knowledge graph that ties everything together from the whole, from data catalog all the way to your machine learning, support advanced analytics, etc., right? So the analysts of this world are really at the point where they say, hey guys, you really need to use semantic technology. And actually, we're kind of proud. We talked a lot about a use case that we had in healthcare to Gartner and Forrester and others in 2020-21. And so in their big report from Gartner about Datafabrics, they used our case study that we do together with Montefiore Hospital. Yeah, a case study, entity event knowledge graphs for powering AI solutions. And if you're interested in the report, we're happy to send it to you. Anyway, so I've given several. So what I want to do, what I would like to maybe use your help is, could we create like a maturity stack for data lakes or lake houses that use full semantics, right? I mean, what would be the elements? Now, I had an earlier maturity stack specifically for healthcare that I presented several times in the year 2017. Data lakes were already around the corner, although Gartner was also already saying, go jump in your data lake, mostly because all the data governance was missing from data lakes, right? So basically you had a big garbage bin with data, but very hard to get the data out. And I think everything that came after that was to add some kind of semantics to your data lake to make it easier to extract data and do your analytics on top of that. And I think the Lakehouses are the latest version of that. But so here's the maturity stack that I presented in 2017. I said, and this is specifically for healthcare, where we built an entity event knowledge graph together with the hospital, where in this model, we took as our central entity as the patient, and then we took data from hundreds of silos, right? And we took everything that happened to a patient and turned it into a simple event object, where an event is just a thing with a type, like a diagnosis or a test, and a start time and sometimes an end time and a provider, and then a few key value pairs depending on that particular type of event. But that was it, a very simple shape of the data, right? And so, and with that one knowledge graph model, we could support many different types of analytics, from personalized medicine to predictive modeling, translational research, etc., all with the same underlying a data shape and data model. Now, but if you go all the way to level 1, right, then this is where every company starts, right, where you have literally thousands of databases to run all your operations, and you can't do any complex reporting on that, right? So people came up with this idea of the enterprise data warehouse, and in the hospital that we worked with, they have 4 enterprise data warehouse. Teradata, they have a big Oracle enterprise data warehouse. They use Chronicle, which is a dump of the Epic database. In itself has 23,000 tables with way more than 100,000 fields, right? So it's an incredibly complex system. And so what we needed to do, where we in the maturity stack that we were promoting, we said, okay, we need to turn this into an entity event model, right? And I just tried to explain what an entity event was, where everything in any kind of databases was transformed in this little entity. And so that was the first thing that we did, simplify the data in this particular model of patient data. And we added a unified terminology system. So basically we took UMLS with the meta source, Nomad Mesh, LONC, NDC, etc. I mean, 180 different medical, and we all created a uniform model of all these different taxonomies and some ontologies. So you could link anything that happened in the event on ontology and actually link it to the unified terminology system, right? And because we made it so simple, we also could really simplify the ETL, where we had Montefiore built a system where you could inspect the data visually and link it to an ontology of about 350 types of events. And you could have someone that knows the underlying relational databases and someone that knew the ontology sit together, and they could do about a table per 20 minutes. So they got an incredible high level of efficiency using this model. So this is the system that they use to inspect the underlying database. This is a table at the Enterprise Data Warehouse. ER visit ID. You link it to a patient initiated encounter. But anyway, so this is a picture of the system they used. And then we get this entity event model with there's a core entity. There's an event graph. For example, there's an encounter with the diagnostics with an ICD-9 term, which is then linked to the knowledge base where we have well, UMLS and statistical knowledge, etc. And the benefits were that our Sparkle queries were like an order of magnitude simpler than the SQL queries to do actually the same thing. I'm not going to go in details here. And getting a 360 view of a patient was ridiculously simple because in our model, we used every triple about the patient had as the fourth element, the patient identifier. So I can just in Sparkle or in Python say, hey, if this is the patient, then print the 360 of the patient, and boom, I get an JSON object, or in Python, a Java a dictionary object, right? That then an application developer can instantly play with. Anyway, then we linked it to open data and other knowledge. We created a sharded version of AllegroGraph so we could go as big as we wanted, right? In terms of the number of patients and how many triples per patient you had. Not important here, but it's important that we got to that point, and then ultimately we had a data science platform on top where, and this was in 2017, with 9, we don't use it anymore, but the cool thing there was that you have data scientists, right, that need to know Sparkle to get features into their feature factors that they can do their analytics on. And so basically this required that every data scientist knew knew how to work with Sparkle, right? And all the representations in the knowledge graph. So we together came up with the model where we actually created another language called the frame description logic, where for every feature that you might want to have for your machine learning, we turn that into a JSON object or a dictionary object in Python. So if you wanted to create a feature factor, you basically just made in Python a list of all the features you wanted, and per feature the parameters like the time and whether there's exceptions that you would allow, etc. So parameterized dictionaries, and the whole system would automatically do all the underlying Sparkle queries to fill your Panda objects that you then can do your analytics on, right? And then when we did the analytics, we always would take the results, turn it into a new graph itself, and then put that information back in the knowledge graph. So you create a learning system, right? And even nowadays, when you look at the descriptions of Lakehouses and Datafabrics, the concept of learning doesn't happen. But if you really want to be ahead, right, you have to add learning to your platforms. Anyway, so this was then. And I'm kind of want to do the maturity stack again at some point. I didn't have time for this presentation to look at this, but there's a whole bunch of things I learned in the last 5-6 years from my customers. Wells Fargo knowledge graphs, Montefiore Hospital has made huge improvements to what they're doing. We're working with a big pharmaceutical company, and we learned a lot about this whole concept of semantic layers over the years. And so I want to do this again with new terminologies. Actually, while we did this in the last 7 years, we also now have the entity event trees in a telco, right? Except the events are very different events. We did it in an intelligent call center, where our core entities are the companies that you call all the time. You can learn about them. With an event graph where there's the reach out of agents to their customers. And then we have a knowledge basis where we have knowledge about campaigns, agent clients, and et cetera. So the model has been successful. Oh, and we have a beautiful entity event graph for aircraft maintenance. Again, you have an aircraft, you have maintenance records and things that go wrong while flying, right? So we have an event graph, but then linked to a huge FAA ontology. It's one of the biggest I've ever seen that they worked on for 10 years. Anyway, so this model is working, it's taking, and it's going forward. So now let me go back to the maturity stack, and I'm just going to make some notes on my stack. And where I need to add stuff, but I probably have to do a completely new maturity stack. But here's the things that I learned, right? It's all about the data catalog, right? I guess you guys in your work see that also, right? I mean, if you don't have a really good data catalog that links your IT structures to your domain taxonomies and ontologies, you really have got nothing. So that is one incredibly important thing that wasn't even in my first maturity stack. And the second thing that we neglected initially is, and what I see literally in every project that we're doing where we help customers build knowledge graph, is access to the data and the bureaucracy of who can see the governance, right? Who can see what data and for how long, right? Based on roles or goals, et cetera, and I'm still looking around to see if we should build even a model, an ontology for how you want to do the maturity, and maybe, sorry, how you want to do the permission engineering. And maybe anyone in your group is already working on something like that, right? But we see this as the biggest bottleneck in any project that we do, right? Is there's no fluid link from data via the data protectors to the knowledge graphs that you want to build. And it's very hard to automate that track. And again, if anyone wants to say something about it, or we can wait a little bit before we do that. Then what can another note is, so we see that the entity event model, that customers are starting to use it, right? We now see that real-time streaming is becoming very important. And so we see the use of Kafka and or systems like Kafka become more and more prominent. One of the things that we then also see is that in these systems, objects like, say, JSON structures fly around all over the place, right? And in the hospital that we work with, the leader there has ultimately decided that you cannot send just JSON objects around anymore. You have to give a type and a unique ID to every JSON object, because it became too confusing, right? So JSON LD is a fairly complex standard, but if you make sure that you give it at least a unique identity, and you make sure that you make sure that you give it a type, right? Then at least you have a chance to be more systematic about your data and find data back later. And then so we've been for the last 10 years working on this whole thing about how important it is to have events. But now you see the same thing. This is a Gartner picture from 2023, right? That tries to sketch the development for the last like 20 years, right? So we first had separate, right, the custom relational databases, data marts, and data warehouses, right? And slowly we started adding a common semantic layer. We got the introduction of data lakes, right? And now we're in the 2020s, right? And now you see that event stores become very important, and all the other AI things that you want to use around this. And just to give you, this picture comes from this report, very interesting to read. The Gartner, it's about application platforms and architecture, where event native intelligence is now becoming important, right? So it's not about state anymore, but it is about what other things happen and can I make automated decisions in real time. And so this is a picture that I've been talking about for a long time, is that in many cases you have relational databases that capture the state of the world, right? But if you want to make decisions in real time, right, you better make the event at the heart of your system, right? And so anyway, just a plug for this whole idea of event processing. And again, I would love to talk about it with you guys. What you think about it, whether you see that in your industry. Then continuing my maturity stack, I don't have to explain the importance of taxonomies and ontologies anymore. Although what I now see is that some companies need a data catalog just for the taxonomies. So we're working with a big pharma company, and they have so many vocabularies lying around that they need even a catalog of that, right? But the ETL part, I think that scripts are Stone Age technology, right? I mean, basically the knowledge about how you go from raw data to your, say, knowledge graph or something else. If you do it in scripts, that basically means that the knowledge is in the head of people that know how to read these scripts, right? And it's not declarative. Every ETL should be declarative and connect business ontology to the data catalog, right? So that's an important part. And then for the data scientists, because I mean, you do all this work, right? So you can analyze your data better, right? And
There's a hand up. Someone's got a question.
Yeah.
Someone has a question. Gregory.
Yeah. Okay.
Yeah. Hi, Jans. So as you know, I'm a physician, so I'm loving this, and I love technology.
Yeah.
Right, two questions came up, and I think you're kind of getting to the analytics layer here. So you had said that it was important to turn the analytic output back into the, I'm not sure where you plug that back in, but back into the graph in a sense.
Yeah.
And so my question was, how did you approach, did you need another ontology or taxonomy to sort of categorize the analytic output? Because I'm assuming that data is not the same as the raw clinical data that you're drawing from. So how did you organize analytics sort of ontologically?
Okay, so 2 answers. One, Parsa Haji, my partner at Montefiore, and I wrote a patent called the Analytic Tapestry, where we proposed that there should be an ontology just for this, right? And I could show you pictures. I would have to look that up, or maybe we can do that in a separate topic, but I can show you how, say you do a cluster analytics, right? So now I have an analytic with a unique ID, and it has a type, which is, say, k-means clustering, right? And then I will tell you what data sources and at what time I did it, and I will give you the main clusters and the weights of the input features on each of the clusters, and then a link to the patients that load on these clusters, right? So you can imagine it's a graph. If you do a k-means k-means clustering, right, or topological analysis, right? Well, then you can imagine that you need a data structure, right, to tie all of that together. Plus, for the analytics, you want to also say who did the analytics, right, and what kind of software you use for that. Does that make sense? Very important in healthcare.
Yeah.
So always go back and have full provenance of from where did these results come from, so that if you do an analytics a year later, you get different results. You have a fighting chance to go back and say, okay, so did the data change? Did my program change? And you get my point, right?
Would it be something like, if you wanted a count of diabetics that were admitted to the hospital, that value of count of diabetics, right? You would want to link that back to maybe do an ICD-9 code, but not, it means it only linked back to individual patients, and it's just sort of a count. I mean, so what do you do with that analytical result, and do you tie it back into the clinical data, or just back, because you were saying there's a feedback. It wasn't just that this had come from individual patient records, but you had summarized it and then fed it back into the graph.
Oh, we also put it, no. So the other thing is, say, so you have, say, patients with diabetics and problems, retinal problems, right? Vision problems. So for example, and something we did topological analysis, right? So that's kind of a clustering techniques that makes way smaller clusters than you normally get in k-means. And we found 22 different types of people with diabetics, right? And so we assigned every diabetic patient with retinal problems to a number from 1 to 22, right? And then we looked at the efficiency of certain medications for these patients. So what you create is a learning system where first you do your analytics, you add the result of the analytic to the patient, with of course a back pointer to where the analytics came from. And then you can do follow-up questions, follow-up queries, or follow-up analytics where the cluster number becomes an element of your analytics. Does that make sense?
Yeah, I guess I'm just wondering about the summary level data. What's the ontology for the institutional level data? Like, you know, number of infections in your ICU or something like that. You're tracking a metric, but is there ontology for all those sort of clinical high level results?
Yeah. Well, we kind of right now have our own proprietary way of summarizing these reports, right? But I think we really need an industry standard for that, right? So that you cross hospitals can compare, right? And we don't
so second question, thank you for that. The second question was your event-based clinical ontology makes a lot of sense. I'm just curious whether you've found data lake data or that streaming JSON data to be more valuable as the sort of source of truth, or what you're actually going about to map and analyze. Is event-based data actually better for an event-based ontology than a data warehouse?
Well, so the philosophy behind the entity event model is that you never change the shape of your data. You only add types of event, right? So it's a model where you don't need to do boil the ocean at once, right? You can add events to patients slowly over time. The shape of your queries don't change that much. I'm not answering your question. Can you ask the question?
No,
again?
so it's more so it's streaming data versus static data, like a data warehouse.
Oh yeah,
like,
yeah.
Which is more valuable as a source for what you're trying to do analytically and sort of clinically?
So in the hospital in Montefiore, they focus way more on clinical care, right? So there's two main use cases. There's many of them, but one use case is cohort. Finding cohorts, right? And then you need the static data. You need the historical data, which has a lot of summarized data about patient, like is the patient diabetic? Did this patient have this type of diabetes at some point? Did get medication? Then this happened after. So that's sort of the higher level aggregation. But for clinical care, like does someone need to be intubated, or will someone possibly get sepsis, right? Then you need the streaming data, and you're only interested in the last 24, 48 hours, right? It depends on the use case, whether you want to have the streaming data for real-time clinical care, or whether it's to find cohorts for a particular clinical trial, right?
Was your stack focused on just that sort of data warehouse then, or how much did you get into that streaming data?
So we can support both, but right now there's a movement in the hospital where we're working on a concept called the hyperstore, where we add a timescale DB to a knowledge graph, right? Because one of the things that is real hard in any database, including a graph database, is do temporal analysis, right? Where you say find all the patients where first this happened and then that, where each of the things itself are linked again to an ontology of concepts. And so most databases are not set up for this very complicated temporal analysis. And so now we get these databases like Timescale DB or others, right, that are more focused. And we're trying to figure out how to do a better combination of knowledge graph and temporal databases, if that makes sense.
Well, yeah, and I would think your event-based ontology would be a step in that direction, right?
Yes, it's definitely a step in that direction, right? Yeah. But
you.
with the knowledge graph, you can't store data that comes in per second, right? I mean, our granularity is data that comes in on an hourly basis. That is what we can deal with. It's not like second by second changes, right? You want to store that somewhere else.
All right. Thank you very much.
Yeah. Okay, but this actually was also the point where I wanted to stop, right? So how could we draw a modern, truly semantic lakehouse semantic layer data maturity stack? It's a bad sentence, but let me stop sharing. Or Let's see if I can get back to my browser. So anyway, I hope I didn't see your faces, so I couldn't see how you received this. Uh, but thank you for challenging me to give this talk about this. Kind of fun to have ChatGPT work with me, right? To create a to create a talk.
Have another question from Chris. Go ahead.
Yeah.
So yeah, on the subject of ChatGPT,
Yeah.
I really enjoyed the way you used ChatGPT, and I thought you exposed a lot of the power of it and also some of the limitations in doing that.
Yeah.
But the question I have really is, when we talk about the semantic layer, are you exploring using the kind of technology that's in ChatGPT to be part of that semantic layer?
If we're using ChatGPT?
Not necessarily ChatGPT, but the similar technology, the use of large language models, training those to do things. I mean, like, for example, you talked about using k-means cluster analysis for something. Did you also consider using a large language model and training it to do the cluster analysis rather than the k-means algorithm? There are various ways that technology, I think, might be applied. I'm just wondering if you started thinking about that, since you clearly have done a lot with thinking about ChatGPT.
Well, for event analysis, so our core, one of our core capabilities is to look at series of events and predict what the next event is going to be, right? And we use the probably the best technology for that is recurrent neural networks, and graph neural networks. So that's what we focus on a lot. We don't use ChatGPT for that, although we do use ChatGPT for many other things in our company. I mean, I am a cognitive scientist. I'm deeply aware of all the things that are wrong with it. But if you look at it as a language machine, just like you look as a calculator, like a counting machine, right? Then ChatGPT is just awesome. So one of the things we do is we analyze natural language, right? And we had linguists that would write rules to simplify sentences and then rules to turn simplified sentences into triples, right? So you could kind of do natural language understanding where you went from text to literally a structured story with events and relationships and concepts. And we found that we could make our linguists like at least 20, maybe 100 times more efficient by having ChatGPT write those language rules for us. So that is I'm real soon at some point. Well, I'll give a talk about that at some place, right, where we show the efficiency of writing rules for language analytics. So that's where we really use the power of ChatGPT, right?
So
with the human in the loop, by the way, right? Because you never
you need the human in the loop, right?
You can never trust ChatGPT. I make
yeah, I like the slide where you asked it to summarize in less than 7 bullets, and it came up with exactly 7 bullets. So it either doesn't understand it less than, or it can't count.
But no, yeah,
they were good bullets.
Yeah, they were good bullets. Yeah, I'm just writing a paper about how we got a new partner in our work, right? And which is ChatGPT, and I'm trying to describe how in a future world in our domain you have knowledge graphs plus large language models plus humans have to work together with the human in the loop, right? And so I have a bunch of scenarios where a knowledge graph has structured knowledge, right? And schemas and maybe world models, but it's highly uncreative, right? And you have to do a lot of work to get something useful out of it. And ChatGPT has read everything in the medical literature and in Wikipedia and knows so much, right? But you never can trust the output ever, right? and then you have human beings, right? That well, they haven't seen as many facts, but they have some unique capabilities, right, to look and do further research and kind of and help
Right.
ChatGPT and knowledge graph, right, to
Because
get better knowledge.
you can't trust individual humans either. I mean, if someone produces a research paper, they get it peer reviewed by a group.
Yeah.
And I guess you apply the same principle even to ChatGPT.
Oh yes, yes, yes,
Got-
yes, yes.
Two other hands up here. Adam Kimball, you're up. We can't hear you, sorry. Doesn't show you're muted, but
Well, if Adam starts
Nope.
talking about ChatGPT, it won't stop, right? So it's not there. Not there.
here, we'll jump over to Philippe and then we'll come back to you, Adam.
Yeah, so I really like these semantic events and distribution of events and really checking the events on the wire on the service bus. And I was thinking of the distribution, democratization of the typings. So you would have your ontological model, but you need to distribute that in the bus in general. So how are you checking in your case that you had there? How did you distribute that and get adoption for using the ontology and the taxonomy across the ecosystem?
Can you ask that question again with other words?
Yeah. so I was thinking, so you had the type model of how everything should look in JSON, which is basically a representation of the knowledge that is passing. So if I understand it as
That's the
semantic
360.
events,
That's the 360 model. That is like a syntactic translation of the triples.
exactly.
It's a syntactic representation of the triples. I mean,
And
literally, right?
yeah. And what I was thinking is that you have multiple systems participating in this network of systems that do a lot of data exchange. And getting a representation out there is a significant challenge in most cases because you need adoption at scale. And so I was curious about that adoption at scale and how to get it. What did you see there that was the big challenges, and did you overcome them? And so I was kind of unpacking that part of it because it's an important part.
Well, I can tell you that at the hospital, they wanted to use JSON LD for all communications, right?
Makes sense.
Yeah, and every JSON LD object, as I said, but Java libraries had big trouble with JSON LD. They were not built for JSON LD. So we kind of undressed the JSON LD into just having an identifier, a type, and patient identifier, right, for every JSON object. So that's enough to solve any problem, right? I mean, that's well, you get the point. If you know the patient, the type, and of course a timestamp, right? So and then the translation into events is almost syntactic, right? I mean, it's super easy. Sorry, straightforward.
Yeah.
All right, Adam, back to you.
Is it working now? Can you hear me?
Yep, gotcha.
Get a nod. All right, cool. Thanks. Sorry about that last thing. All right, Jan, thanks. I would love to participate in the maturity model thing. I think it's super fascinating. And I didn't even realize I was missing a step, which is like realigning all of your semantic data, which I see too happening, especially in life sciences, where so many people got wind of this technology and created sometimes some questionable artifacts along the way. And now you have to go back and realign all of that stuff that was meant to align things. That's fascinating. But one question I had early on for somebody like you, who's been, so deep in this world for so long, which is, how is it possible that an entire kind of paradigm and a framework that we all here believe in has managed to just not ever reach any sort of critical attention for as long as it did? You started off with, how come no RDF anywhere? Like, to you specifically, why do you think that's the case? And as a community, what have we failed at, which we could have maybe changed? And I know that things can still grow and change, and hopefully we're right on the precipice, but a lot of us have been feeling like we've been on the precipice for like a decade plus, and so it hasn't happened, and therefore I'm starting to think, well, maybe they're right.
Yeah, that's the crucial question, right? It's Adam, your guess is as good as mine. I mean, to begin with, right? We're 1% of a percent of the budget of IT, right? And so there's this massive economy, a massive economy maintained by people that know how to do things, right? I think it starts with people, right? And so say you're a big company and you want to get into semantics, right? So you hire Accenture, right? You say, okay, give me a team of 100 people to make this, right? Well, you pay an enormous amount of money, right? But if you don't have the right visionary in that group of people, right? You get a half-assed, really unhappy solution. When I was still a professor in industrial design in the Netherlands, right? I had one PhD student who wrote a thesis about 5 different technologies and how it took 4 or 5 iterations before the technology made it, right? So for example, the fax, right? It started already when the telephone was invented. They instantly had a fax, right? To transmit zeros and ones. And several times over the last century, they tried to introduce the fax until it finally hit it. I don't know, was it in the early 70s that the fax suddenly made it? Same thing for the video telephone, right? Several attempts to make a video phone, and then we never got it because the laptop it actually ultimately manifested in on our screens like how we sit now, right? So I don't know this. I don't know what the breaking event will be to ultimately get to the point. I mean, it really helps that Gartner and Forrester are now promoting, right? That you're really old-fashioned if you don't have a data fabric, and a data fabric needs a knowledge graph, right? Maybe that will be a big difference, right?
Cool, thanks.
But then of course then there's again the fight between the property graph databases, right? We don't need semantics, and then we do need semantics, right? So that is the other. Yeah, sorry.
Yep, we've got about 60 seconds. Greg, we'll give you kind of the last one here.
In your ontology, both for the events, and then I think you had tied that into some of the UMLS code sets for medical ontologies. How much did inferencing play a role in the work? I mean, how much did you actually sort of end up inferring from these mappings of, one table that has an A1C and one that has a hemoglobin A1C, right? You had to say those are the same thing. Was that a manual process, or were you able to leverage inferencing to do that work?
So we already integrated all these different taxonomies, right? So you have the meta-thesaurus and LONIC and SNOMED, MESH and NDC and what have you, RX norm, right? And the whole shebang. And we already integrated those, right? As much as possible. Then ICD-9 and ICD-10, right, are mapped to those things. So that is easy. With the omics data, there's like 3-4 systems, right? That for translating from a gene, and Hugo is one of them. And we haven't done that work yet to do the integration. I mean, we're not really a life science company, right? I'm waiting for the bio-ontology people, right, to do an integration of these different systems, or at least the mapping, right? And then it becomes easy.
Okay.
But we're actually right in the middle of this problem, right? Because we're looking at clinical trials, and even within the same company, they use different vocabularies, right?
Yeah, and I mean, I guess that should be the power of a semantic technology to give you that inferencing. So I've heard people sort of down talk inferencing in semantic technologies because in the real world it never ends up getting used. So just curious if you found you were able to get to that sort of mono state of the machine doing things for you.
Well, you've got, even within ICD-9, you have we need a lot of inferencing, right? Because sometimes you want to talk about diabetes patients, sometimes you want to have the full ICD-9 tree, right? And and because in your data you get a thing 3 levels down, but you still want to be able to talk about this as a diabetes patient, right? So their inferencing is really important.
Okay.
Yeah.
Very good.
All right. Well, I think it's time.
Yep. Well, thank you very much for joining us here today and sharing the update. If you happen to have any of the links for the Gartner Forrester links, Steve Case was asking in the chat if have any of those that are available that you might be able to forward. We'd love to see them, but I will get today's recording up and emailed out to everybody, and we'll look forward to seeing everybody here next month.
All right. Okay. It's my pleasure.
Thank you.
Thank you very much.
Okay. Bye.
Thank you.